So observe very carefully, everybody. So as we know that Kepler's first law will says that, so the planets are revolving around the sun. As we know that we are having a two axis. One is minor axis. Another one is which axis? Major axis. Now that it is having a two focus. That is what F1 and F2. So sun is present at any one of the focus, either F1 or F2, and planets are revolving around the sun in a particular elliptical orbit. So that is what elliptical orbit. That is what we studied Kepler's first law. Sun is present at any one of the foci and planets are revolving around the sun in a particular elliptical path. Is it yes or no, guys? Is it yes, everybody? That is what we used to say Kepler's first law, or we can say law of, what is the first law called as?
Law of orbit.
Orbit. Now coming to the second law, if we take the Kepler's second law, so again as we know that sometimes the planet will come closer to the sun, sometimes the planet will go far away from the sun. Now you tell me, where it will travel very faster, closer to the sun or far away from the sun? Yes, please.
Closer to the sun.
Whenever the planet is closer to the sun, it will travel faster. It will travel faster because of more gravitational force. So whenever it is far away from the sun, then the speed is minimum, as it is the force of attraction is minimum. Now, if we'll take a particular time interval, that is what, let me take from A to B, in a given period of time, the sun will travel some distance, and same way from another same equal interval of time, the sun is the planet is traveled from C to D. Now, if we'll join the line between these positions and if we'll find the area, then as we know that law of areas, what is that areas? A1 is equals to A2. That is what the planet always will sweeps equal distance or equal area in equal interval of time. That is what we studied law of areas. That is what we can say Kepler's second law of planetary motion. Is it yes or no? Yes, please. All of you?
Sir.
Yeah, it is closer to the sun, travel faster, but in a given period of time, the area covered by that is equal to the, even though the planet is far away from the sun, in a same period, the area covered by that is equal to this one. That is only we can say law of areas. Now, today's class, we are going to study law of periods. So let us understand what is this law of periods so that it will be helpful for us to understand the typical things and all. From this only the numericals also will come in our future also 11th and 12th class all. Based upon third law, it will be lot of concepts will be going to interlink. That is why understand this concept very carefully. Okay, I think this Thyaya Kumar is Divyasri, I think. Please rename yourself. A call to absentees. Now, observe very carefully. Law of periods means, do you all know that what is the planets revolving around the sun? Anybody? One by one, you tell me. What are the planets revolving around the sun?
Sir, Mercury, Venus, Earth.
Mercury, Venus, or Jupiter, whatever it is, Neptune. Now, my question is it all the planets is revolving in the same elliptical orbit, all different elliptical orbit? Yes, please. Different elliptical orbits or same elliptical orbit? Is it all the planets are revolving in the same path or different paths around the sun?
Different.
Yes, please.
Different path.
Different path. That is, I understand everybody. So now if we'll take, if this is the path of the Mercury, then here is the sun. If we'll take, then Mercury, this is the path of the Mercury. Now if we'll take, Earth is a which planet from the sun? Earth is a planet number what? Yeah.
Third planet, sir.
Third planet. So now if we take, different planets is revolving in a different orbits around the sun. Is it yes or no, guys? Yes, please respond everybody. Now, if we take, observe very carefully. Also, if we'll see, if I join the line between the planet and the sun, is it constant or varies? If I'll join, for example, planet 1 to the sun, and if I'll join the sun and the planet 2, if I'll join the sun and the planet 3, understanding? Now, is it the distance is the line joining is remains constant or it will varies? Anybody? Is it constant or varies? Answer to my question, please. Ready? Open your mouth. Is it same or different, guys?
The line varies.
Is it
Varies.
it will varies? Yes or no? So if you notice, the line joining a planet and the sun is not constant for each and every position of the planet. I understand everybody? But it will take, as we know that, if the shape of the orbit of a planet is circular, then what is that, guys? If I consider, for example, the same P1 planet is here, the same planet is here, the same planet is here. Now, I will join the line between the sun and the planet. Is it every time the line is same? Is the every time line is same? I'm asking. Now, let me take now P3. Planet 3 is here. Now, planet 3 is here. Now, planet 3 is here. Now, I will join the line. Is it the line is same every time? The distance is same?
No, sir.
No. But if I consider, for example, if the orbit is in a circular path, then you tell me, if here suppose P1 is there. Now, if I'll join the line between the sun, then what? Always. Then what it is? Respond, everybody.
Equal distance.
Then it is always equal distance. Now, if I'll take the planet 2, now, if the planet 2 is here, 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 I already taught you this concept. So now the distance between the planet is same or different, the line joining. Yes, please. Nobody will answer. If you try to
Same,
answer,
sir.
correct, Mr. Harish Jairas, what is happening? So if you take the orbit of a planet is circular, then the length of the line joining the sun and the planet will be constant, and the radius of the orbit is also constant. Is it yes or no? But basically it is what shape? It is not the circular shape. What is the shape of that orbit? What is the shape of this orbit? What is the shape
Elliptical.
of this orbit?
Elliptical.
Elliptical. Take nothing, guys. Understand very carefully. In elliptical shape, the line joining between the points from the planet is not constant for each and every position of the planet. But if you consider, if the shape of the orbit of a planet is what? If you consider, what is the shape of the planet? Orbit. Yes,
Circular
please.
path.
If the orbit shape is circle, then always the line joining, the length of the line joining the sun and the planet will be constant, and that is what we can say is the radius of the orbit. Is it yes or no, Mr. Reddy, Mr. Akilan? That is what we can say radius. Yes? In the case of circular. Now, if we take, since the orbits of the planets are elliptical in shape, and the distances of the planets from the sun and the planets is not constant throughout. So that is why we will consider the average distance, average distances and average radius of the orbit. I understand, Mitakshri, what I am trying to say. So as it is, if it is the circular shape, we can say always radius is the distance between the planet and the sun. But as it is elliptical shape, the distance between the sun and the planet is not constant for every position. That is why if the distance is not constant, physics first chapter, what we will take? Sometimes more distance, sometimes less distance. Sometimes more distance, sometimes less distance. So we have to be taken what? We have taken what? Average speed. Do you remember, Reddy? Do you remember, Hari? Sometimes more distance will travel, sometimes less distance will travel. So that what we will calculate? Like that means body. We'll calculate what? Average speed. So same way here, due to the elliptical shape, sometimes the planet is closer to the sun, Sometimes the planet is far away from the sun. So that is why we people are taking average distance between the planet and the sun. So that average distance only we can say, then average radius also. Are you understand everybody what I am trying to say, Mitakshri? Yes, please. Then we have to consider it is not constant throughout. That is why we have to consider the average of the distances called average radius of the orbit. Average of the distances is considered average radius. Is it okay, Mr. Harish? Average
Yes, sir.
radius between the planet and the sun. Understand, Mitakshri, Divya, Akilan? I am considering it. That is what
Yes,
it
sir.
is. Now, if you'll understand this concept, so I consider constant radius or average radius? Average radius or constant radius?
Average.
Average reading.
Average radius. Understand?
Average.
Now, average radius of the orbit. So now, according to the Kepler's third law, that is what, according to the Kepler's third law of planetary motion, all of you should understand the square of the period of revolution of a planet around the sun. I am repeating again, understand everybody. If I consider the average of the distances called average radius of the orbit, then according to Kepler's third law of planetary motion, the square of the time period of revolution of a planet around the sun. What is the time period means? Time period, how we can represent? Which letter? Which letter? Capital T. Do you understand, everyone? So time period, what is Kepler's third law means? The square of the time period of planet around the sun is directly proportional to the cube of the average radius of the orbit. Cube of the average radius of the orbit. That is what we used to call as Kepler's third law. Can I repeat once again? Please answer. Gokul, Akilan. It will take the time period. For example, the earth, what is the time period taken by the earth revolving around the sun? Anybody? What is the time taken by the earth revolving around the sun? Please respond, guys. What is the time taken by the earth revolving around the sun? I am asking. Can you understand my question? 365 days. That is only is equals to how many years? 1 year.
1 year, sir.
Understand? So like this, different planets will having different time period revolving around the sun. Now, the Kepler's third law will says that, and as well as different planets is having different radius or not, everyone? Yes, please respond. So different planets is having different radius. So now let me consider this is the P1, planet 1. Now this is the planet 1. This is the planet 1 from the sun. So if I consider this average distance, average radius is R, then it will take certain time to revolve around the sun. Is it yes or no, guys? Is it yes or no?
Yes, sir.
Yes,
Then
sir.
the square of time period of revolution around the sun is directly proportional to cube root of average radius of the orbit. Now, if I'll take the next planet, let me take this is P2 and this is P2 and this is P2 and this is P2. Now, this planet is having different time period. Is it yes or no? This planet is having different time period or not?
Yes, sir.
And this planet is also having different average radius. Is it yes or no? Then the time period of the second planet is square of that is directly proportional to average radius of the cube root of average radius of the second planet. Are you understand, Mitakshri? For every planet, square of the time period is directly proportional to cube root of average radius of the orbit. That is only called as Kepler's third law of planetary motion, or we can say what we used to call. What is another name? Law of periods, we can say. Understand, Mr. Gokul? Please answer to my question.
Yes, sir.
Yes, Mr. Omar. So basically, orbits are elliptical in shape. But if you consider if it is a circular, then always the distance between the planet and the sun is remains constant. That is what we can say radius. So that is why, as it is not a circular in shape, it is an elliptical in shape. That is why instead of taking the individual radius, what radius we are taking, guys? We are taking what? Average distance is only called as average radius of the orbit, which we are considering as r, because of elliptical path. So different planet is having different time period and a different average radius. So for every planet, the square of time period of understanding planet revolve around the sun is directly proportional to the cube of the average radius of the planet of orbit. That is only called as Kepler's third law. Is it okay, guys? Or called as law of periods. Any doubt, anybody can ask me, please. I understand? Yes? Write it.
Yes, sir.
Right. According to Kepler's third law of planetary motion, according to this all noted down. I'm giving 2 minutes time. You can please note it down, all of you. So why we are considering here average of the distances is called average radius? What is the reason? Anybody can tell me? What is the reason behind? Mr. Johan? What is the reason behind? Why are you considering average radius? Anybody? Mr. Harish Jairaj? Akilan?
Because there are different radius, sir.
Because of sometimes planet is closer to the sun, because of sometimes planet is far away from the sun. What orbit it is? It is elliptical orbit or circular orbit?
Elliptical orbit.
Elliptical orbit. That is the reason we are considering average radius of the orbit, because of its elliptical shape. You have to use that word and you have to mention it, all of you. So write it. According to the Kepler's third law, if you are not communicating lifelong, you will never improve. I am saying again, Mr. Johan and Harini, everybody I am saying. Those who are not communicating, you will never improve lifelong. Your choice now. I don't want, I am losing my temper, I am saying. Very, very bad it is. How many times I should beg you people? Write it. According to the Kepler's third law of planetary motion, at least you can say, yes, sir, understand, sir, not understand, sir. Something you should say. What is happening? Are you 9th class only correct? You are not LKG or UKG people. Right. According to the Kepler's third law of planetary motion, comma, the square of the period of revolution, write neatly, the square of the period means what? Time period. Understand? Square of the period of revolution of a planet. Revolution of a planet around the sun. So what we should represent? T square. Okay. Around the sun is directly proportional to the directly proportional to the cube of the what, guys? You should tell me. Cube of the what? Gokul?
Average radius.
Average radius of the planet's orbit. Average radius of the planet's orbit. So what is that called as? We have to consider as a what? Cube root they are considered. So R cube. So then now you can write the relation. So time period, square of time period is equals to cube root of average radius of the planet's orbit. This is only called as Kepler's third law. Mr. Omar, have you understand? Harish Jairaj, Pitakshri, that is what it is. Right. Any doubt, anybody can ask me, please. That is only called as Kepler's third law. Okay, Hari, ready?
Yes, sir.
Yes, sir.
Observe very carefully. If the period of revolution of two planets are given, let me take two planets. If I'll take two planets, then is it both are same or different? Two planets, if I'll take two planets, is it same or different? That is what my question. Everybody. If I'll take
Different, sir.
planets, all of you observe, this is one planet, and I will take, this is the another planet. Now, I am keeping inside, you can see here, this is the two planets, guys. Now I am taking, the sun is present. Is it the time period is both are time period is same or different? That is what my question. Yes, please. This is the sun. Okay, guys. So this is the sun. Now is the time period is same for both or different? I am asking. Everybody answer. This is the planet 1. Now this is the another planet 2. Now is it both the planets time period is same, guys, or different, guys? Can you understand what I am
Different,
asking?
sir.
Different time period, same time period. Different planets is there in different orbits. So definitely once they are revolving around the sun, they will be having a different time period. Yes or no?
Yes, sir.
Yes.
Yes, sir.
Let me consider, and also the line joining between the two planets is also not same because radius is not same. So that average radius, this is same and this is same. Now let me consider the time period taken for the planet 1 is T1 and the time period taken for the planet 2 is what? Planet 2 is what? T2. Okay. Then the average radii of the orbits are R1 and R2. Average radii is what? What is the average radii? Radii. Radii means what? Radii is the plural form of radius. Is it okay, Mitakshri, Divya? No response at all. Radii is the plural form of radius. Now, if the time period is T1, then what is the average radii? Average radii is what? R1. And if the time period is T2, average radii is R2. Please note it down. Average radii is R2. Average radii is R2. I will make it now. See different positions. Same planet is in different positions. So average radii is what I consider, guys. What is the average radii?
R2.
R2. Everybody make it. I'll draw the line also. See, that is what no book will draw the diagrams to understand. So why I am making to make you better understanding so that you people will never confuse in the concepts. So average radii, first planet average radii, what I consider? First planet average radii is the second planet average radii is what I can consider second planet average radii? R2. I will change the line color so that you people can understand. Is it okay now? Mr. Reddy, Gokul, no response.
Yes, sir.
See now, is it okay with us? See now, is it clear? See, I am drawing the different colors
Yes,
line so that you people can easily understand. So that line 1, black color for planets and red color for planet 2, I am drawing so that you people can understand easily. So you want to change the color also, you can change. This planet is some other color so that it will be easy for you people to make it. You can make it with one pencil. If you don't have pencil, red pen, blue pen, like that you can change black pen so that it is easy for you people to understand. So this is what planet 1 and planet 2. Is it okay, guys? So the time taken for the planet 1, what I consider, guys? T1, and the average radius is what? Average radius is what? R1. And the time taken to planet 2, and average radius is what? R2. Then if you'll notice it, the both planets, if you'll take, is it the same or different? Everyone, Mr. Hari, same or different? For planet 1, time period is same, time period is different, average radius is different. And planet 2, time period is different, and average radius is different. Is it right or wrong? Is it right or wrong, everyone? Now,
Yes.
if I do the ratio of this one, T1 square is directly proportional to what? We know that cube of R1. Understand? And T2 is directly proportional to, what is that? Square of T2. Square of T2 is directly proportional to what? Cube root of R2. Now in mathematics, you people knows very well, if you want to remove the proportionality, I want to bring the equals to, then what I should do? Anybody?
Add case.
So that constant.
Constant, sir.
I should bring some constant. Is it yes or no? Everyone, please respond. So T1 square is equals to constant into R1 cube. Is it right or wrong? Yes, please.
Yes, sir.
Now,
Yes,
here you tell me, Reddy, what will happen, Mr. Akilan? T2 square. T2 square is equals to, what will come? Everybody.
K R1 cubes.
No, constant into R2 cube, cube root of R2. Is it right or wrong, everybody? Yes, please. All of you.
Yes, sir.
Now, can I write this one as R1 cube is in multiplication. Will come this side, what will become, guys? Anybody?
Division.
Division. So can I write it as a T1 square divided by cube root of R1 is equals to constant. Can I write it, Mitakshri? Divya?
Yes, sir.
Now same way. Second equation, tell me, what is this one? What is this one? T2 square divided by R cube root of R2. It is also, can I write it as a constant? Can I write it as a constant? Yes, please.
Yes, sir.
yes.
Then if you'll notice it, if both are remains constant means, then I can I equate this both are equal? See, remains constant, that constant is same. If we'll calculate the ratio of T1 square divided by R1 cube, same way T2 square divided by R2 cube, then remains you'll get the same constant. For every planet, if we'll do the ratio of square of time period divided by cube root of average radius, remains you will get the same constant. Understand? So that is why if we'll consider the two planets, T1 square divided by cube root of R1, which is equals to T2 square divided by cube root of R2. That is what, which is equals to what, guys? Which is equals to what? Constant. Okay, so please make it. That is what I want to say. So that is why I have made you to do this one. So everything is constant. So this is only referred as, what is to call? What is this law name as?
Law of
Half period.
Periods. Have you understand, everybody? Mr. Kaushik?
Yes, sir.
Any doubt, ask me. That is what. Mr. Johan, at least respond in chat. Yes or no, Divya? This is only, right? Statement you write. If the period of revolution of two planets, this diagram also you should draw. If the period of revolution of two planets, are T1 and T2. Mr. Omar, understand, Omar? Johan? T1 and T2, comma, and the average radii of their orbits and their average radii of their orbits are average radii of their orbits are R1 and R2. R1 and R2. R1 and R2. R1 and R2, comma, respectively, comma, then T1 square divided by R1 cube is equals to T2 square divided by R2 cube is equals to constant. That's all, guys. Just make it, please. Then that is what it is. Is it okay, guys? Yes, please.
Yes, sir.
Yes, sir.
Yeah, make it and solve it this all neatly. I hope everybody understand how I brought the constant. If you want to remove the proportionality, this is the called as proportionality. So if you want to remove the proportionality, so what we have to bring in mathematics? We have to bring the what? Equals to sign, then we have to bring some constant. That constant is every planet, that constant is remains same. So that is what I am saying. Nothing is big. Is it okay, guys? Yes, write it now, everybody. Any doubt, anybody can ask. Is it clear, guys? Once you understand, please let me know. Okay, now you all people studied in the physics second chapter, Newton's third law, Newton's first law. That's all the things we studied. Do you remember Newton's first law, Newton's second law, Newton's third law? Everybody?
Yes, sir.
Yeah. So that is only. Now, can anybody tell me what is Newton's first law, second law, third law?
First law of inertia, second law F is equal to ma, third law F is equal to minus.
Yes, very good. F is equals to, that is what reaction is equals to, action is equals to minus reaction. That is what it is. Is it yes? Yes or no? Okay. So now, this is what is called as Kepler, Newton's three laws. That is what Newton's law of inertia, Newton's F is equals to ma, and the third one is called as, we can say, action is equals to minus reaction. Even that is also now it is important, as it is when we are going to study the next concept is Newton's law of, understand, gravitation, or you can say universal law of gravitation, as it is very important. Very if you know this Newton's three laws, and as well as if you understand this Kepler's three laws, then with the help of this only, Mr. Sir Isaac Newton has been derived a law called as universal law of gravitation. So that is what we are going to study now. So I hope everybody understand this. Now, if you want to solve, let us solve one example related to even this one. That is what the distance, this formula, what I have given you just now. So that distance formula also you can solve. That question I also will give you as a homework. You can try. If you want, then tomorrow's class also we can discuss. Now, we are going to study the next one is Newton's law of universal gravitation. Please all of you keep heading. What we are going to study now? Newton's law of universal gravitation, or we can say Newton's law of gravitation, or we can say law of gravitation. Whatever it is, all are same. Newton's universal law of gravitation. All of you keep heading. Newton's universal law of gravitation. So do you all remember the Newton's 3 laws? Second chapter? No doubt, correct? Yes, please.
Yes, sir.
Now, Newton's third law. Let us just revise once. If you want to apply the Newton's third law, is it possible to apply in a single body, or if you want to, you need how many bodies? If you want to apply the Newton's third law, yes, let me know.
2 bodies, sir.
2 bodies. So it is not possible. What is the first Newton's third law? Everybody, there is action, then action is equals to what? Reaction.
Opposite
Yes or no? So now if we'll take the 2 bodies, this body will hit the second body, then only the second body also will hit the first body. So that is what we can say. If Newton's, the force applied by the first body and second body we used to call it as action, and then the force applied by the second body and first body we used to call it as what? We used to
Reaction.
call it as reaction. So action and reaction both are same direction or different direction always?
Different direction.
Different direction, opposite direction to each other. If action is in forward direction, reaction is in backward direction. That is why we can represent always with what sign? Minus sign. Now,